All right, here's 3.5e, part 3, solving rational equations, okay? So when one or both sides of a rational equation have a sum or a difference, you're going to make sure you multiply each side of the equation by the LCD to eliminate the fractions. The goal is to basically not have to work with fractions, but to turn it into a linear or quadratic or something that you're familiar solving. So first thing you want to do is find the LCD of all the denominators. You may need to factor. You want to multiply all terms by the LCD, divide and simplify, and then use inverse operations to set one side equal to 0, factor if possible, zero product property, meaning that if you set each product equal to 0 and solve for x, then there's your solution. And then check your solutions by plugging it back into the original rational equation. So first example we have here is 6 over x plus x over 2 equals 4. Step 1 is for me to identify my LCD. So my LCD for this problem is, what is my common denominator? It would just be 2x, right? So my LCD would be 2x. That means I'm going to multiply each numerator by what the denominator is missing, okay? So that it's all over one fraction. And the reason why we want it all over one fraction is because once your denominators are the same, all you're doing is solving the numerators, okay? So when I look here at 6 over x, x is missing 2. So that means I'm going to have to multiply the numerator and denominator by 2. Okay, when we look here, we're going to look at the denominator. The denominator is missing an x. So I'm going to multiply the numerator and the denominator by x. When I look at the 4 denominator is technically a 1. Ask for the friendly 1. So in order for it to have the LCD, I'm going to have to multiply the numerator and denominator by 2x. Is what we're doing. So when it's all said and done, I'm going to end up with 2 times 6 plus x times x equals 4 times 2x. And all of that would be over the same denominator. Because once they all have the same denominator, all you have to do is worry about your numerator. So the denominator is now irrelevant, and you're just going to solve from here. So we end up with 2 times 6 is going to give us 12. X times x is x squared. 4 times 2x gives us 8x, okay? So we multiply all terms by the LCD. There was nothing to divide and simplify. Well, we're going to divide, simplify if need to, but we're now at the simplify. We're going to use, there's nothing to divide and simplify. We're now at the inverse operations because we want to get one side equal to 0. So we're going to subtract 8x. When I subtract it, it has nothing to combine with on the other side. So we're just left with, I'm going to write it in decreasing order of power. So x squared minus 8x plus 12 equals 0. Now this is just a quadratic, a simple quadratic at that. So I'm just going to factor it. So I'm asking myself what multiplies to give me 12, what adds to give me negative 8. And that would be x minus 6 and x minus 2. That's because negative 6 plus negative 2 is negative 8, and negative 6 times negative 2 is positive 12. Okay, so from there, I can now say that x equals 6 and x equals 2 are my two possible solutions. Okay, so the last step is saying to check your solutions in original rational. So I'm going to go back to the original and plug in the values and see what happens. So I'm going to check 6 first. So checking with x equals 6. That's going to look like this. So we have 6 over 6 plus 6 over 2, and we want to know, does it equal 4? 6 over 6 is 1. 6 over 2 is 3. Does 3 equal 4? And the answer is yes. So x equals 6 is a possible answer. We're going to do the same thing with x equals 2. We're going to plug it in for x. So we have 6 over 2 plus 2 over 2. Let me get some of that extra out. 2 over 2. And we want to know, does it equal 4? We get 6 over 2 is 3. Plus 2 over 2 is 1. And that equals 4. So we know our two answers are x equals 6 and x equals 2. Okay. All right. So here are some further examples. If you would like, I would like for you to pause right now. And then you can try this one on your own and see how it goes. All right, you're back. So let's see what happens now. So here we have 2 over x plus 1 over x. So the LCD for this problem is just going to be x, right? So that means that these two can be combined already. But this side, remember, it's 3 over 1. I'm going to multiply the top and the bottom by x. So we're now working with 2 plus 1 over x equals 3x over x. So your denominators are the same. So denominator doesn't matter. All you have to do is worry about the numerator. Okay? So 2 plus 1 is 3 equals 3x. So therefore, to get x by itself, we would divide by 3. And so x equals 1. Okay, I'm going to check to make sure this works out. So going back to the original, if I let x equals 1, I have 2 over 1 plus 1 over 1. Does it equal 3? And it does. So I know that x equals 1 is my answer. All right, this one's a little more complex. So here we actually have, we haven't really brought up difference of cubes in a while, but this is a difference of 2 cubes. So we have a difference of 2 cubes here. How do I know they're cubed? Because x to the third, and then 27 is 3 to the third. So we have difference of 2 cubes. So it's going to be helpful to fully factor so that we can figure out what our LCD is. So we have 1 over x minus 3 equals x minus 4. Remember, when you're doing difference of cubes, you're taking the cube root. So we end up with x minus 3. That's our first factor. But then our second is actually going to be x cubed. Hold on. My thing is doing something weird. Okay, so we left off with the difference of cubes. I have no clue why I wrote square there. So when you're finding the difference of cubes, it is going to be x minus 3. Let me write it out, the rules at the bottom, just to remind you. So sum and difference of cubes. If I have a cubed, it's a weird looking thing. A cubed minus b cubed, it equals the binomial a minus b, which is just the cube root of your a term and the cube root of your b term, times a squared. It's going to always be the opposite. So if it's minus here, then it's going to be plus here, plus a times b, and it's always positive at the end, b squared. Okay. And then if you have a cubed plus b cubed, it equals, again, always the opposite on the binomial, meant the same on the binomial, opposite on the first term of the trinomial, a plus b times a squared minus a times b plus b squared. Okay, so those are going to be our rules that we follow. All right, so here we have x minus 3. Cube root of x cubed is x. Cube root of 27 is 3. So it's going to give us x squared plus x times 3 is 3x plus 3 squared is going to give us 9. So those are our factors. All right, so then after we identify our factors, we want to look at our LCD. Well, our LCD is this. That's going to be the least common denominator. So this denominator is missing the trinomial x cubed plus 3x plus 9. So what that means is I'm going to have to multiply 1 times x cubed plus 3x plus 9. So I'm multiplying 1 times x squared plus 3x plus 9. Okay, now once I multiply 1 and also your denominator, the denominator no longer matters because the denominators are going to be the same. So all I have to do is focus on the numerator. So we have x squared plus 3x plus 9 equals x minus 4. Okay, after this, we want to get one side equal to 0. So I'm going to subtract x and add 4. Subtracting x and adding 4. Okay, that's going to give me x squared plus 2x plus 13 equals 0. Okay, so it's asking you, now we're down to solving this out. So on this one right here, this isn't going to be an easy, pretty, factorable situation. So what ends up happening here, we're going to have to use a quadratic formula. Okay, sorry. So we're going to use the quadratic formula. So remembering the quadratic formula. So in order to do the quadratic formula, you're going to need an extra piece of paper because we don't have enough room in this space to do it. So I'm just going to create my little extra piece of paper by covering this bad boy up. But remembering the quadratic formula, so your quadratic formula, that's where we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? So your A, that's your A, your leading coefficient. So A, your B, and your C. So when you're plugging to the quadratic, we end up with x equals negative 2 plus or minus the square root of 2 squared minus 4 AC divided by 2A. So we're going to do some math here. So we have negative 2 plus or minus the square root of 4 minus, and 13 times 4 is going to give us 52 all over 2. So this equals negative 2 plus or minus the square root. 4 minus 52 gives us negative 48 over 2. Okay, we've talked about this before. Oh no, we have a negative. So that means that there is no real solution for this. It's going to be an imaginary solution. In order for this to be true, it would have to be an imaginary solution. And so when we have the square root of negative 48, remember 48 can be broke down to 16 times 3, right? So this is the same thing as taking out the I, and then we would have square root of 16 times the square root of 3, right? So we have the square root of 16 times square root of 3. So this equals negative 2 plus or minus square root of 16 is 4. We have our I because it's negative square root of 3 over 2. And this is what our x would be. Our approximate value of x would be this guy, the imaginary, okay? So it doesn't give us a real. We end up with an imaginary. All right, we're going to do the last one. So on the last one over here, we have 6 over x minus 1 plus 2x over x minus 2, right? So for this one, our LCD is actually going to be, so the LCD here is actually x minus 1 times x minus 2. It's going to be both of the denominators multiplied together because they have no common factors already. So I'm going to have to multiply by what they're missing. So x minus 1 is missing x minus 2. So I'm multiplying the top and the bottom by x minus 2. X minus 2 is missing x minus 1. So I'm multiplying the top and bottom by x minus 1. Okay. And my altogether, this is over 1. So this is missing x minus 1 and x minus 2. So I'm multiplying altogether x minus 1, x minus 2 to the entire numerator here. What's that going to happen? What's the purpose? Is so that we can eliminate our denominators. We don't have to worry about them now because we found what would be missing to make them equal. So what this would look like in terms of putting it all together, I would have 6x minus 2 plus 2x times x minus 1 all over x minus 1 times x minus 2 equals 2 times x minus 1, x minus 2, all over x minus 1, x minus 2, which is why now our denominators are the same, which is why all we have to do is focus on the numerators. Okay, so our numerators are going to distribute and combine like terms and then proceed to solve. So here on the first one, I'm going to distribute 6. I'm going to distribute the 2x. I'm going to FOIL and then distribute the 2, however I want to do it on that side as well. So we end up with 6x minus 12 plus 2x squared minus 2x equals 2 times, and we have x squared minus 2x minus 1x. Let me see if I can write that a little tighter together. x squared minus 2x minus 1x plus 2.
I'm not gonna be here 8th period, so I was gonna get the number.
Okay, so now we're going to finish. We're going to combine like terms and finish it out. So over here, I'm going to distribute the 2. So I have 2x squared. This is going to be -2 and -1 makes -3. So I'm going to go ahead and write -6x plus 12 equals, and over here, I have 2x squared. And then 6x and -4x make positive 4x. 6x and -2x make 4x minus 12. So notice I have 2x squared on both sides, so it's going to cancel each other out. And then I'm going to combine like terms and get, in this case, it's just going to be x by itself. So I add 6x. And that gives me 10x minus 12 equals 12. I'm going to add 12. And I get 10x equals 24. Then I divide by 10. So then we end up with x equals 2.4. Okay, then I can go back, plug it in, test it out, make sure I did it right. I would suggest using your calculator to check it and going there. Okay, on the back. All right, on the back, you have these problems. And the goal for the back here is I just want to make sure that you understand how to combine them. And if you're not comfortable with finding a greatest common factor, I mean, a least common denominator, this is a good time for you to practice. So again, you want to make sure everything's fully factored. I'm going to use GCF to factor out 3, and it's going to give me x minus 4. So when I factor that out, I can see that the LCD is going to be 3x minus 4. So this is my LCD. 3 times x minus 4. So that means in order for me to only have to worry about the numerator, I need for everyone to be over 3 times x minus 4. So this fraction, the first fraction, it's not missing anything. It has 3, it has x minus 4, it's good to go. The second fraction in the denominator, it needs a 3. What I do to the bottom, I have to do to the top. The last fraction here, it has 3, but it doesn't have x minus 4. So it needs x minus 4. What you do to the bottom, you're going to do to the top. And now you're going to multiply your little cells out. So we have 7 minus 3 all over 3 times x minus 4 on the left side equals 2 times x minus 4 all over 3 times x minus 4. And now my denominators are the same. So in order to solve, I just have to worry about the numerator. So 7 minus 3 is 4. So we get 4 equals 2 times x minus 4. A lot of times you guys want to distribute first, but when it's something you can see that can be easily divided, you might as well just divide. So I can easily divide by 2 here. And that's going to give me 2 equals x minus 4. I'm going to add 4. And I end up with x equals 6. So the solution here would be x equals